Tuhia ki te rangi, tuhia ki te whenua, tuhia ki te naka o ngā tangata, ko te mea nui, ko te aroha, tihe moriora. And while you read the translation, my question to you is that we all have a role to play. We all have something that we're particularly passionate about, purposeful about. And as we enter this age of ecological crises, which we've actually sort of already entered already, it's worth just always reflecting, what am I going to do? How am I going to play? How am I going to be effective, an advocate, a change agent in this big shift that's coming at us? The building code is less than inadequate. It's actually a sort of a negative investment model where the buildings we build leak health, leak energy, leak water, they grow molds for us. That's a little apartment building just next door to Jasmax. And so they're not very good, so we chuck them in a skip. And I've got to say, although Auckland has got a lot better in the last couple of years in processing waste, the rest of the country has a long, long way to go. This is a typical refurbishment. We've got ceramics, cardboard, plastics, electrical. And of course, the last thing they chuck on the skip are all the fluorescent tubes, which then break. And as the truck drives down the road, the mercury vapor leaks out, etc., introducing toxins into our environment. Climate change is front of mind for everybody. This is a bit of a mishmash of Ministry for the Environment and NIWA data. The reality is that for the last 20, 30 years, everything we've been told is always the minimum impact that the scientists and the politicians can agree on that they want to share with us. As we know, very little has been done to address carbon over the last 20, 30 years. So we're going to be looking at the higher end of all these sea level rises, increase in storm intensity, rain intensity, temperature, and the health issues that go with them. But part of my point today is that it's bigger than just climate change. We're human beings, Homo sapiens. We came out of several millennia of evolution. We're actually part of nature, and we are nature. But the way that we structure our society, the way we structure our education, the roles, professional roles we play, we're very much silo operators. We look at things in isolation. And then when we fix something over here, we wonder why it pops its ugly head up over here. Who's seen a red-billed gull on the beach this summer? Anybody spotted it? A little red bill? They tend to hang around humans, so typically you'll see more of them. But I just found out the other day that there are the same number of red-billed gulls as there are kiwis in New Zealand, approximately 60,000 breeding pairs. Actually, at every level, across every part of the system, we're degrading the health of the ecosystem. And if we don't have an ecosystem, there is no society, there's no economy, there's no built environment for sure. So sitting behind my talk today is the fact that we have to start understanding that we have a role to play in the system. Kaitiakitanga, stewardship. So it's really important. It's a bit like, how do we nurture and grow the land to be productive, to look after people, and to be healthy too? And that's kind of really where I'm coming from, and that's what motivates me. Big picture, rising population, increase in consumption of everything, and increase in toxicity. And at the same time, the health, the ability of the biosystem, the living system to support life, is degrading severely. So we will get to a crunch, we're reaching some crunch points already around climate and climate change and carbon in the atmosphere. But there are many other indicators that are giving us a really serious food for thought on how do we approach this. So this is an interesting quote. The major problems of the world are the result of the difference between the way nature works and the way people think. That's just what I was saying earlier. You know, you ask an engineer to solve a structural beam calculation, he's not that fussed about the stormwater outside. So we need to start increasing our ability to work as systems thinkers and to take a broader outlook when we're, for instance, starting on projects. We can hone down to the details later. But typically, the image on the left is what we've been delivering for the last 100 years. You know, put it in a concrete channel and get it away. But then the picture on the right is actually a restored, that's the concrete taken out and the stream restored. Slows down floodwater, habitat for life, more birds, bees, insects. Actually, the water's cleaner. It's stopping all the sediments washing down into the sea, which prevent the fish from breeding. So starting to align our thinking towards being nature, operating like nature, is a great starter. It's a little quote from Ngāi Tūhoi that we picked up when we're working with them, and I'm going to talk a little bit about that project at the end. It's very pertinent. So a lot of people find this image sort of useful. If you think of the horizontal axis, below that, the projects, the infrastructure that we're building have negative social, cultural, environmental, and economic impacts. And above the line, having positive impacts. And we can see over on the left-hand side, that's the sort of the building code area, the lowest legal compliance level that we can work to. If you don't do the building code, well, in fact, you're breaking the law. You could end up in prison. It's not really where we want to be. And then gradually, as we start to get into green, we're thinking, okay, less energy used, less water used, more health, but less bad health, and building awareness and understanding. And sustainability is this kind of neutral space that doesn't really exist in the middle. In a sense, just aiming for sustainability is a bit of a low-hanging fruit, a bit of an uninspiring goal. So I'd encourage us to think beyond that. And a colleague of mine, a good friend and acquaintance, Bill Reed, describes sustainability as a slower way to die. That idea that by reducing the impacts we're having, then we get to the Death Star more slowly. And look, that's a little mean on one level, but the work around reducing our impacts, it's what I call sort of footprinting or housekeeping, is really, really critical. But the space that interests me is sort of more on the right-hand side of this diagram. And specifically, this sort of circle here is where the Living Building Challenge framework starts to become useful to us. But when we're looking at regenerating the living system, we start to think less about a green building and more about a building as being like an acupuncture point. When we're dropping a building in, that building's ability to stimulate the health of the environment, the ecosystem that it's going into. And we don't really have time to talk a lot about that today, but it is a bit of a swap around from sort of thinking about the object to start thinking about the system. And essentially, the idea is that when we're in the regenerative space, what we're really doing is creating habitat for life, for all life. So obviously humans are pretty important, but if we don't have the insects, the birds, the whales, the healthy farming systems, then we won't be around for very long. So the Living Building Challenge came out of Seattle in 2006. It's been through a few iterations, and it asks a really simple question. What does good look like? If we're putting all this energy, all this design time, all this investment, all this thinking into our projects, how do we know when they're good? How do we know when we've had some measure of success? I'll just give you a quick overview. There's 7 petals. So under place, limits to growth. You can only build living buildings on brown or grey field sites, not green fields. You have to grow food on your building. You actually have to offset the land that you're building the building on with a donation to Forest and Bird or a conservation organisation, and really promoting human-powered living, biking, e-biking, scootering, running, walking, you name it. Net positive water, mimic the ecological water flow on the site. So as if when you put your building on there, the rainfall, the groundwater can flow and leave the site in a, if not as good, but a better state than it came onto the site. Net positive energy, generate 105% of the energy requirements of a building on an annual basis. Healthy indoor environments, biophilic, connecting people to nature. Materials is quite interesting. Trying to eliminate toxic chemicals from our buildings and from our cities, homes, and the whole life cycle of manufacturing, production, use, end of life. Another offset, the embodied carbon that it took to build the building, buying offsets for that, sourcing local material, and reimagining waste, not just as reducing it, but actually how does waste become a positive stream of resources for future projects. There's a section on equity, which actually has a third offset. You have to make a charitable donation. And then, of course, we want our buildings to be beautiful and to lift our spirit and to educate people. So just a quick flip over to Melbourne. This is a farm on top of a 2.5 hectare shopping centre that's being built just outside Melbourne. It's actually got a Countdown in it. Countdown have had to go through their standard spec and work out what to do to get their red list compliance, reduce their refrigeration for food down to an absolutely tiny amount compared to standard. So if you said to somebody, hey, you're going to put a farm on top of your shopping centre, typically your developer will be going, Jerome, don't be so bloody stupid. What actually eventuated is that the actuaries who calculate the retail value of shopping centres said, look, this is a hit. This is going to attract a lot more people to this shopping centre. They're growing food, they're running education, cooking classes, the children can hang out here while parents are shopping. It actually increases foot traffic by 10% and therefore the metre square yield of this shopping centre by 10%. Buildings, 20%, food, 20% of our carbon footprint. So in actual fact, making our food local, not farming it, trucking it, distribution centre, packaging it in plastic, supermarket, driving to the supermarket, throwing a third of it away, etc., etc. We need to be having a culture of food right around where we live. Quick trip to Seattle, the first certified commercial office building in the world. If this building had been built to building code, it needed 6,000 square metres of solar electric panels, built to the local energy code, just over 4,000, built to net positive energy, 1,300 square metres. This building actually operates around 90%, uses 90% less energy than a building code building. So it's really smashing the footprint. It's really smashing the carbon. Certified house over in Point Chev, no heating, generates all its own energy. They put quite a large solar electric array on the house because their actual long-term plan was to pump that into the electric car that they've just purchased. And rather than just offsetting grid electricity, offset their fossil fuels used in travelling around the city. Expand that up to the city, the village within the city scale, and you start to see what's possible around local energy grids, pushing the cars off to one side because they have a huge impact on our carbon profile, and actually making just a really a community, a people-focused space. This treats its own wastewater, and that water flows through the site into a stream, and that's how you walk around the site, following the stream through the path. Built primarily out of timber to sequester carbon, and applying those same philosophies to educational buildings. This is the new Architecture and Engineering School at ARA at Christchurch, 6,600 square metres, designed to be low carbon. It's got a primary timber structure, it's got a solid timber enclosure to the inside of the envelope, and designed to be net zero energy in this instance. So this is the Coastlines building, built by the charity Sustainable Coastlines. They're surfers and they don't like surfing in plastic sewage. So they started a charity to educate people, not just about not dropping plastic, but all the endocrine and hormone replicating chemicals that are in plastic that leak into the water and then work their way through the food chain and affecting, how fish breed and actually eventually how humans breed as well. But the trick with this project, they're heading towards certification. It's pretty much 80% waste and salvage products to build this building. Old shipping containers, old pallets. Up on the right, their office is actually an ex-Samsung show house, demonstration house for all the Samsung TVs and computers and stuff. So we're imagining a pretty low carbon footprint for this project. They will be certifying. So the materials panel, just to recap, has red list, trying to get rid of toxic chemicals. It requires us to offset the embodied carbon that it took to build the building. All timber and quarrying stuff has to be FSC or third-party verified as safe working practices, good environmental impacts. Local sourcing of materials, encouraging local industry. That's quite hard in New Zealand because we have a few thousand kilometres of ocean around us. And again, that idea around net positive waste, turning this building into food for the next building. They have a simple ingredients label for building products to make it easy to understand where it's made, what to do at the end of its life. It's a bit like a food ingredients label, what's in it. And the embodied carbon footprint. This is imperative 11. The project must account for the total embodied carbon impact from its construction through a one-time carbon offset, not necessary in that carbon exchange that they offer, or an approved carbon offset provider. So that immediately means that you must do a life cycle analysis of your building. You've got to do life cycle design. Set some targets at the beginning, evaluate the first stage of the design, and then go back for a third stage and check that you're on track. And then once you've finished it, actually get a certificate. And what we're seeing as we increase the efficiency of our buildings, proportionally the embodied carbon becomes more and more important. So in the 70s, the operational energy was 90% of a building's carbon footprint. Today, it's roughly 60-40, and potentially in the future, because we've provided renewable energy for our buildings and we've set them up with our own water systems, the operational carbon becomes much, much smaller. And we're really focused on the embodied carbon. And this is not quite accurate, as I will explain in just a second. So, has anybody heard of the Tukura Whare, the Tūhoi building? So it's a project that Jasmax and I are particularly proud of. It's the first Living Building Challenge project in New Zealand. And in actual fact, it's the first certified project anywhere in the world outside of the United States of America. So it just demonstrates that New Zealand has this willingness, this motivation, this real desire to do the right thing and to demonstrate what we're capable of here. And it's essentially Ngāi Tūhoi's sort of HQ. On the left is a 2-story office building. It's got a cafe inside, an archive and library, and then a very large meeting space. And I've got to say, I've done a few Green Star projects, but to provide all the evidence to get this certified, it's the first time we've ever done it. It was a real mission. And we actually certified it 3 years after the building was completed. So this idea of forensic architecture, where you're going back through records and spreadsheets trying to find out information. So when you know that you've got to reduce your carbon and you're going to have to pay an offset bill, you start getting really focused on making sure it's a low carbon building. So this is an innovative New Zealand adaptation of a pine log. It's been cored, even drying out, even treatment. You can use it for piles. You can use it for shear panels in the building. You can put cables through those channels and lock them down so when the building's rocking in an earthquake, it's stable. So the only bit of concrete we actually ended up using was the ring beam sitting on top of the piles. And the rest of the building is pretty much built out of timber. You can see major primary timber structures, timber floor. These wrapped up panels are the same poles as the foundations, but just made into the earthquake resisting panels. What does it take? It takes 200 community volunteers to make 5,000 earth bricks. Tūhoi gathered earth and clay from all over the Te Arawiras and brought it to site. And then they made these blocks and everybody carved their name in it. And they became if you like, part of the natural air conditioning of the building. Has a constructed wetland, so the water is treated, if you like, passively, a little bit of pumping, but goes into a septic and then into this constructed wetland. And of course, it's got a pretty significant solar array and solar hot water on the roof. For about 4 months, it was the biggest solar electric array in New Zealand, but rapidly overtaken. So this idea of life cycle analysis, we used a company called eTool in Australia. They offer a certification service and a design service, so that was quite useful. We needed that. But you can just see that, sourcing and extraction of raw materials is a big chunk of the carbon, manufacturing, delivery, distribution, and then in-use and maintenance, and then the end of life still contributes, getting rid of the stuff at the end of the life. This was the embodied carbon comparison that eTool gave us. So you can see a typical large office, 20 kilograms of CO2 equivalent per metre squared of building. And then a small office, slightly more efficient, a similar Living Building Challenge building, and then the Tūhoi building is sitting right down there. It's really a good outcome. But what was really interesting for me, and this is where I always surprise myself with a bit of data. So if you look up here, we've got materials and construction stage. So that's buying the materials, building the building. We've actually got just under 400,000 kgs of carbon. During the use stage, nearly 2.5 times that. So over the life of the building, 100-year life for this building. And then quite a bit still in demolition to get rid of the stuff after you've demolished the building. And then you get a little bit of credit. And so we've recycled some timber or stuff like that, so they give you a bit of credit. So nearly 1,500 tons of carbon over to build, replace the claddings, renew the paint jobs, and look after the building over its 100-year life. Now this is the really interesting thing for me, that of the in-use stage, 60% of that figure is for the solar electric panels on the roof. We're all in a rush to go out and buy solar panels, but because they get replaced over that 100-year life, they get replaced 3 times, and a lot of solar is produced in China using coal-fired power stations. We're actually creating not just a carbon problem, but also a potential waste problem, because they're not very recyclable. But it starts to give you a picture, starts to help you understand that when we get into life cycle design and we have inspiring goals to achieve for our buildings, that we really start to understand how we're going to get this carbon, how we're going to hit the carbon. So the building's certified. For Tūhoe, the tracing of the sun every day is a really important part of their culture. But just going back to the bigger point that I made, you know, we could have 1 million green buildings. We could have 10,000 living building challenge projects. But we may not, if we're not working on the health of the ecosystem that underpins our ability to live on this planet, we don't get out of here alive. So we have to be really cognizant that reducing our impacts is important, growing our handprint, growing the good that we do in the world is really important. But actually, if we aren't working to create habitat for all life, healthy water, healthy fish, healthy farming, healthy food systems, healthy transport systems, we will not win the battle, because there's too many people on the planet to live in the way that we're living currently.